Okay, so this is my mid-unit 3 assignment. So the question was, describe what happens to the domain and range of a logarithmic function under a vertical reflection. Support your explanation with diagrams. So here is my axis, and I use two functions to show this, and this is f of x equals logarithm of x, and the domain and range of this are, the domain is x is the element of a real number, and x is greater than 0, and the range is y is the element of a real number. And here you can see the blue line is the f of x function, and then for the other for the g of x function, g of x is equals negative log of x, and the negative in front of the log of x creates the vertical reflection. And the domain of this function is x is the element of a real number, and x is greater than 0, and the range is y is the element of a real number. And as you can see here, this is the graph of g of x. So the domain and range for both functions stay the same for our vertical reflection. Okay, question 2. Describe what happens to the domain and range of a logarithmic function under both a horizontal and vertical translation. Support your explanation with diagrams. So for this, I use two functions, f of x and g of x. So f of x is the parent function where y equals logarithm of x, and the domain is x is the element of a real number and x is greater than 0, and the range is y is the element of a real number. And here you can see the standard logarithmic equation with both a horizontal and vertical translation applied to it. So the h is the horizontal translation, so it shifts the graph to the left or right, and c is the vertical translation, and it shifts the graph up or down. So for g of x, I use an example to graph on the axis. So g of x equals logarithm of x minus 3 in brackets plus 2, and the domain is x is the element of a real number, and x is greater than 3, and the range is y is the element of a real number. So you can see the two graphs on this axis. So the blue is the parent function, and the g of x is translated 3 units to the right and 2 units up. And so the range stays the same for both functions, but for g of x with the vertical and horizontal translation, the horizontal translation affects the domain. So because it was 3 units to the right, x has to be greater than 3. Okay, question 3. Graph the function f of x equals 1/2 log x minus 4. So it's in blue right here. So I graphed it. And then part A asks, graph the line y equals x on the same grid. So I graphed y equals x in green. And then part B says, graph the inverse function f negative 1 of x by reflecting f of x in the line y equals x. So I reflected it, and that's in red, so this is the inverse function. And then it says, determine the domain, range, and the equation of the asymptote of f of the inverse of f of x. So I did that right here. So the domain is x is the element of a real number, and the range is y is the element of a real number, and y is greater than 0. And the horizontal asymptote is x equals 0. So that's the dotted red line there. Part D asks, determine an equation for for the inverse of f of x. So what I did was I wrote down the original f of x equation, and I replaced f of x with y. Then I flipped the two variables, x and y, so x becomes y on this side and y becomes x on that side. And then I isolate for y, and I ended up with 10 to the power of 2x plus 8.